Hello everyone, welcome to IMS Academy. In this particular session, we are going to revise entire engineering mechanics subject for your GATE 2024 examination. Right? I hope already you have done your preparation part. In this last moment, we have to revise our entire formulas and the concepts, so that we'll be in a position to solve any of the numericals here. Okay, so in this sessions, I will be covering all of the topics of engineering mechanics, which is common for both mechanical and civil engineering students. Okay, now we'll start the session here. See, but before starting the session, you should know there is a Telegram group we are having for IMS GATE Academy students. You can join this group to have a latest notifications regarding your jobs, and you will be having latest informations for the webinars that we are conducting. And also you will be getting the quizzes that will help you in your preparation, technical exam preparation, it will help you. So there is a link already mentioned in the description box also that you can use to join this particular Telegram group, right? Apart from that, whatever sessions we are conducting, like this smart revision sessions, you will get the PDF in this particular Telegram group only, okay? Now, next thing is that I want to discuss here regarding the IMS Academy online programs. Okay, in this IMS GATE Academy live online GATE programs, we are having a content of more than 800 hours. Apart from that, you will be getting the exercise books where you will be getting the question bank, okay, in level wise, like level 1, level 2, level 3, like it is easy, moderate and difficult questions. In different levels, you will be getting the questions for your practice apart from PYQ, right? And one more important feature that we are having in the live program is one-to-one mentorship. So you can have a direct connect with your faculty who is teaching you that particular subject, and you can discuss whatever doubts you are having or whatever challenges you are facing in your GATE preparation. So you will always have a direct connect with the faculty. That's what we are providing in 12 one-to-one mentorship sessions. Okay, and one more thing regarding the online test series, you will be getting the video solutions as well. So to have a free counseling session, you can call on these numbers. Okay, the numbers which is mentioned here, you can directly call on these numbers and you can book your free counseling sessions, and also it is mentioned in the description box, so you can use these numbers to book your free counseling sessions. Now moving ahead, and we'll start the session here. Okay, and the engineering mechanics that we are going to discuss here today. So in this session itself, we will be discussing each and everything regarding the engineering mechanics. So take out your pen and copy and you can make your formula sheets straight away from this sessions, right? Now everyone, so as you know, there are the chapters. First of all, I will tell you the chapters that we are going to discuss here: equilibrium, truss, friction, centroid moment of inertia, vibration. This part is common for both mechanical and civil. Then dynamics and Lagrange equation is only in the mechanical syllabus, not in civil engineering. Civil engineering till this 5th topic you have a syllabus, and last 2 topics is for specifically mechanical engineering students, right? Now we'll be starting the discussion with the equilibrium. Okay, now see, in equilibrium, first of all you need to understand what are the equilibrium conditions for a different force system, and in our syllabus we have to discuss only coplanar forces, right? So 2 conditions we always need to remember if I talk about equilibrium. So first of all, we are talking about a coplanar case, and in coplanar, concurrent force system I am talking about, concurrent force system. So this is concurrent force system, and there is one coplanar non-concurrent force system, coplanar non-concurrent force system, right? Now everyone understand what is concurrent and non-concurrent force system. In concurrent we are having same point of application, but in non-concurrent the point of application will be different. So for example, if I have to mention how it will be, okay, how I can draw this concurrent force system, it will be like this, right? But in coplanar non-concurrent force system, you will have a point of application of the forces will be different, like this. Got it? Now this is non-concurrent, this is concurrent. Now what about the condition, equilibrium condition? Because we are discussing equilibrium, what are the conditions we are having, right? So in this case, basic idea regarding the equilibrium you should always understand, it is representing what? State of balance. State of balance means like which kind of balance you are talking about? Forces balance, okay? So in order to have a equilibrium here, the net resultant force should be 0. and net resultant force will be 0 when you have a resultant value or the net value of the force is 0. So how you can say that value is 0? For that you have to calculate the resultant. If it is coming out to be 0, then you can easily say it is under equilibrium. So we have two equations here, summation of forces along x direction 0 and summation of forces along y direction 0. Okay, so now what is summation of force along x and y? See, basically whatever force you are having, what you will do, basically you will resolve each and every forces in x and y directions. Let's suppose I have drawn this coordinate system, right? This is my coordinate system, this is x and this is y. In xy direction I will resolve all the forces. All the forces along x I will write, all the forces along y direction I will write. If both are individually 0, then only the resultant value will be 0. Now coming to this non-concurrent force system, the first two conditions are remain same. First two conditions are same, but there is one more condition which is summation of moment. Okay, as I told you what? The moment, okay, moment value has to be what? 0. Very good evening, Amit. So this point everyone should understand, guys, please. Summation of force and along x and y direction, it is okay, fine, it is 0. But why the moment? Because when we say equilibrium, it should be what? The state of balance, but balance of forces as well as balance of moment. Because if any net moment is present, it can create a tendency of rotation. And if the tendency of rotation is there, then we cannot say body is under equilibrium condition. So this basic point you should understand, right? Because whenever moment is there, then definitely chances of rotation, tendency of rotation is there. So we need to avoid that situation. That's why we will be putting summation of moment 0. Now about which point? At any point, it should be 0. Okay, you can take any point. All the points should have a net moment value 0. So we have 3 equations for non-concurrent, and for concurrent we have only 2 conditions. So these things we should remember. Okay, this is all about our equilibrium chapter, right? This is the basic thing everyone should understand. Now same concept we have to use in our truss analysis as well. Sometimes you will be having concurrent, sometimes you have non-concurrent cases. So we need to know how to solve this. Okay, so I hope this basic idea is clear. Now how to get the resultant value? For example, we have 2 forces and 2 forces are having angle theta between them. So directly the relation that you need to remember here is under root f1 square plus f2 square plus 2f1 f2 cos theta, right? This is the relation. Now one more thing you should understand from this relation, what is the maximum value of resultant we can have? If I talk about maximum value, it will be f1 plus f2 when theta value is 0, and resultant can have a minimum value possible when theta is 180 degree. So that is f1 minus f2. So your actual resultant will vary between R max and R minimum. Between these values, resultant will vary, right? So this is the first way. So instead of forces, we can have any vectors like velocity, like momentum, okay? Any kind of vector we can have. So this formula resultant we are calculating, it is not just for forces. You can use for any other vectors as well. Velocity, acceleration, momentum vector, any kind of vector you can use here. Because it is giving the resultant of 2 vectors, not actually the forces, resultant of 2 vectors. Okay, so this concept we should remember first. Apart from that, the general method how you will calculate. Okay, so wherever the forces are acting, you need to draw a coordinate system there, right? So let's suppose this is the force F1, okay, this is force F2, this is F3, and this is what? F4. This kind of forces are acting on this particular point. So wherever it is acting, you have to draw the coordinate system. Next step is write down the forces, because you have to resolve all forces about x and y direction. So I will resolve all the forces about x and all the forces about y direction. I will resolve. Then finally, what I have done here, this entire force system has been converted into summation of forces along x and summation of forces along y direction. So this entire force system has been converted into this one. Now 2 forces we are having, again 2 vectors, angle between them 90 degree. So finally your resultant answer here is summation of forces along x direction square plus summation of forces direction along y direction square. Right. Now that's what, if you remember, I've told you regarding the equilibrium condition, summation fx and summation fy both individually 0. Why? Because resultant 0 means both has to be individually 0. Then only you can say resultant 0. And resultant 0 basically means equilibrium condition. Right? So this much basics everyone should understand. So this is the way by which I can calculate the resultant values. Okay. So parallelly with the sessions you have to create the notes. Okay. So all the formulas, all the important concepts I am going to write here itself. Okay. Any doubts, any confusion if you have, you should ask immediately. Okay. One more theorem we are having, that is Lami's theorem, and it is a most important theorem, right? Because some of the question with the Lami's theorem become very easy. Okay. So I will tell you under what cases we can use Lami's theorem. See, if I talk about Lami's theorem, okay, so what happens, let's suppose there is a body and it has been acted by 3 forces. So 3 forces are applied on the body, this F1, F2, F3, and let us assume the angle opposite to F1 is alpha, opposite to F2 it is beta, and opposite to F3 is gamma. And there are 2 conditions that everyone should remember. Okay, this condition has to be what satisfied, then only I can write a relation for Lami's theorem here. Now what is that conditions? See, condition number 1, first of all, body should be in equilibrium. Body is under equilibrium condition. Okay, and only 3 forces should be acting. Only 3 forces are acting. So if this is there, okay, if these 2 conditions are satisfied, then I can apply directly Lami's theorem relation, which is actually a sine rule we are having, okay, which is a sine rule here. So what I will write here, simply F1 divided by the angle opposite to F1 is sine alpha, angle opposite to F2 is sine beta, and F3 is sine gamma. Okay, but actually if you go into detail, from where it came, it is basically the sine rule. If I draw the this diagram, force vector diagram, if I draw here, if I add all the vectors, it will be a closed triangle. And when it is a closed triangle, okay, we can directly apply the sine rule and we will get this relation. But remember, body should be in equilibrium and only 3 forces are there. And as a result of it, okay, one more point you should write here. As a result of it, what happens? All 3 forces must be concurrent. All 3 forces must be concurrent. Right? So remember this point, everyone. Whenever body is under equilibrium, it is given in the question, let's suppose, and only 3 forces are acting. So all 3 forces must be under concurrent case. Okay, all the 3 forces must be concurrent means the point of application is same. Okay, body under equilibrium and only 3 forces are acting. The forces must be concurrent. This is very, very important point that we should understand, and it will help you to draw the correct free body diagram. Okay, it will help you to draw the correct free body diagram. Most of the time we are doing mistake in drawing the free body diagram only, and if you have drawn wrong free body diagram, definitely you will be getting a wrong answer only. So in engineering mechanics, the first step is to draw the correct free body diagram, right? So understanding of Lami's theorem is also very important. Now, one more thing regarding moment. Now everyone knows like how to calculate a moment, but still many times we will do mistake here also because of the only one point that we actually miss. Okay, so moment of force, just I'm telling you the point where actually most of the students are doing mistakes. Okay, now see. So there is a body here, and on this body, let us assume some force P is acting. You want to calculate a moment about point A. Okay, I want to calculate a moment about point A because of this force P. So what it will be? Simply always remember the line of action of the force. Line of action of the force. So you have to multiply the force multiplied by some distance. But what is that distance? that distance is actually the perpendicular distance taken from the line of action to your point of consideration. Okay, from your line of action you have taken perpendicular distance d, which is actually known as moment arm. Right. So moment arm, most of the time we are writing wrong values here in moment arm. So that's why we got wrong answers also. Please remember this thing. Force multiplied by distance, correct. But what kind of distance we are talking about? The distance from the line of action, perpendicular distance from line of action to your point of consideration. This is very important point. Okay, so other than that, everyone knows like force into distance. While writing the moment, we always do mistake in this moment arm value only. Okay, so this thing we should remember. Now this is a simple way of writing moment, but in terms of vector, how you will write? In terms of vector, it is written as r cross f. Now what is r? R is a position vector, f is also your force vector. Now r vector usually written as x dot I y j dot j cap plus z k cap. Okay, x I cap, y j cap and z k cap. And what about the force vector? It is fx I cap, fy j cap, fz k cap, like this. So position vector, force vector we have written. So in terms of force, in terms of vector, basically moment can be written as r cross f. Okay, this much basics at least we should know. But in most of the cases, your work will be done using this formula only. But remember, don't do mistake in moment arm. Right, everyone? Done. Next, one more concept, Varignon's theorem. Okay, Varignon's theorem that we need to understand. Okay, Varignon's theorem. Now, actually what happens, let's suppose there is a body we are having, and in this body, there are two forces acting. Let's suppose this is F1 and this is F2. And let us assume you want to calculate a moment, okay, about point A. So how you will calculate? You will say, sir, simply the line of action of F1 I will take, line of action of force F1, okay, and line of action of force F2. So that distance, this distance is, let's suppose, d2, and that distance is basically d1. So if I have to calculate the moment because of all the forces present in this system about point A, what I will do, F1 moment about point A, it is F1 into d1, and it is in clockwise sense. Let's suppose clockwise moment I am taking positive. F2 will have an anti-clockwise, so I will use negative sign, F2 d2. So it can be positive or negative, any value it will have. Okay, don't worry about the sign. Only point what I am telling here is, whatever kind of force system you are having, and if I ask calculate the moment about point A, you will calculate very easily by proper sign convention. Clockwise positive, so then anti-clockwise will be negative. If anti-clockwise positive, clockwise will be negative. Simple. So that is fine. But the moment produced by all the concurrent forces together, the moment produced by all the forces, all the concurrent forces together will be equal to the moment produced by the resultant alone. That is what the Varignon's theorem. Now, F1, F2, two forces, they will have some resultant value. Okay, so let me write the resultant value here. So same body, assume the same body we are having, and let's suppose this is point B. At point B, we will have some resultant R value, right? And this is point A. So the moment produced at point A because of this resultant is R into, let's suppose, some D. D is the distance taken from the line of action of resultant. Okay. So perpendicular distance I will be taking, this distance is D, perpendicular distance. So the moment produced by the resultant alone at the same point okay, is R into D. So as per Varignon's theorem, the moment produced by the resultant alone will be equal to the moment produced by the all the forces together at the same point. That is what Varignon's theorem. Okay, this theorem is very, very important, guys. Okay, so basic logic is all the concurrent forces together, it will have some moment about any point. Same moment resultant will also produce, but alone. Resultant also will produce same moment. So finally, from this concept, let's suppose here and here two equations are there. So I will write resultant moment and summation of the moment because of all the forces about the same point. I can use it. This concept I can use it. This is what known as Varignon's theorem. Correct? Is this point clear, everyone? Tell me, everyone fast. Right, so that's all about our equilibrium chapter. Okay, this is what we need to understand in equilibrium chapter. Now, quickly we'll move on to the trust chapter here. Okay. So basically we'll be discussing all the concepts that is what required. Okay. So in the last time we will be having again quick revisions. So for quick revisions we'll be focusing on the important formulas and relations only. In trust, two important concepts I will tell you. Zero force member and method of section. If that is what clear to you, then you can solve any of the problem. So quickly we'll discuss what is zero force member. Okay, in zero force member what happens? There is a case 1. A joint formed by two members, but both the members are non-collinear. So this is member 1, this is member 2. Remember, what is the condition? Case 1, joint formed by member 1 and 2. Okay, joint formed by member 1 and 2, and both are non-collinear members. This is very important point. And at the joint there is no load and no support direction. Under that case, both the members will be a zero force member, and we will get this answer, this result, final result will be getting very easily if you apply the basic equilibrium equations. Second case of zero force member, joint formed by three members. Out of three, two are collinear. Out of three, two are collinear. Third one become automatically the zero force member. Again, condition provided no load and no support direction at the joint. So these two cases we need to remember, very important, and this zero force concept actually will simplify the truss analysis problem. So if you remember the zero force concept, it will help you to analyze the truss analysis, truss quotient very easily. You can do it. The analysis of truss. What do you want to do in analysis of truss? Force calculations only. So if you know this concept, the problem become very easy for you, right? Apart from zero force member, what is the next thing that we need to know? The method of section. Method of joint everyone knows. Simply equilibrium equations we have to apply. But how to apply the method of section? The approach is not clear. From where we have to start? In method of joint, okay, we know. Simply equation, equilibrium equation 1 and 2 we will apply, we will get the answer. But in method of section, what is the correct approach? From where we have to start? That is the biggest challenge that most of the students are facing. Okay, so I will just tell you the approach here, no matter what kind of question they have given for truss analysis. We will apply method of section. Why? Because it will take very less time to solve the question. Method of joint also we can apply, but it will be taking more time, right? And in the competitive examination, it's all about the time management. Okay, so let's quickly discuss this method of section. Okay, now let me just draw the one truss here for you. Okay, so let's suppose this is the hinge support here and this is what the roller support we are having. Oh, okay, let's suppose the namings I am giving here A, B, C, D, it is E and this is F. Okay, and let's suppose some forces are applied here. Let's suppose this is force P and this is force Q. So to P and Q, some external forces are applied on the truss. Now, how to solve this kind of problem with the method of section? That is a very important question here. See, let's suppose they are asking force in member FC. For example, I am taking one simple case here. From that simple case, you can solve any of the problem. Now, please focus here. Force in member FC you want to find out. Okay, force in member FC. Okay, so what I will do? I will cut the truss with the method of with any section. In method of section is what? We are using section and cut the truss. How to take the section here? Which section? And that section is passing through which members? That is what the basic doubt we are having. So let's suppose they have asked FC member, as I told you also. So your section should be passing through that member, and while passing through that member, you have to ensure one thing. It should not cut more than 3 members. It should not cut more than 3 members. Why? What is the reason? Because if it is cutting more than 3 members, we will not be in a situation to solve the question. But why? Because we have only 3 equations of equilibrium. At max, your section should cut only 3 members. Remember this point. So if I have to find out force in member FC, I will use this method, this section basically. This section I will be using. Let's suppose this is section XX. With this section I will cut. And remember, whenever you are using a section to cut a truss should get divided into 2 different parts. Okay, it should get divided into 2 different parts. This is very important point. Now when you have cut it like this, now the remaining truss, how you will draw? See, remaining truss. Okay. See, remaining truss you will be drawing like this. This is the member which has been cut. Okay. This is one of the member which is cut. This is also cut, and this is also cut. So this is the left portion I am drawing. Some reaction RA it will be having, and this is what the load, external load P is acting here. So this member, cut member, is force in member FE. It is force in member FE. This is force in member FC, and this is force in member BC. So I can take left portion or right portion, it's up to you. Okay, you can take left or right based on your convenience. Reaction we can easily find out using equilibrium equation. That is the basic step. Whether it is method of joint or method of section, that is the very first step. Calculate the support reactions. Okay. If I ask you, if I want to calculate force in member FE, let's suppose one by one all 3 I will calculate. What is the concept I will use? See, here we need to understand all the questions we can solve, all the unknown values we can solve with single line. With single line I can solve FE also, FC also, BC also. Okay, so first of all, for force in member FE, what I will use? What is the equation? See, whenever we are using equation, we have to ensure one thing. In that equation, only this one should be the unknown. If other than this also are coming, then we can't solve the equation. Because equation with one variable only we can solve. Na? If more than 2 variable with one equation, how it is possible to solve it? Okay, it is not possible to solve. That's why whatever equation you are using, make sure that this is the only unknown. Other 2 values should not come. Okay, but before that, you should say, sir, what are the equations we are having? Summation of forces horizontal 0, summation of forces in vertical, that is y direction 0, and third summation of moment is 0. These are the 3 equations we are having. Okay, any of the 3 equation I can use. Now force in member FE. If I use summation of forces horizontal 0, so FE is there. Apart from FE, BC will also come into picture. Again, not possible to solve. Summation of forces vertical, not possible to use. Why? FE is itself horizontal. So how you can use this equation? Not possible. Third option, summation of moment 0. But about which point? That is the question here. We should take that point where FC and BC moment values are 0. So the only possible option we have is point C. At point C, FC moment and BC moment will be 0 because they are passing through point C. So I will write summation of moment about point C 0, and I will get the direct answer with this equation. Right, now let's suppose for force in member FC, which equation you will write? Again, horizontal, is it possible? Yes, we can write. FC will have horizontal component, but again BC is also unknown, not possible. Summation of forces vertical, yes, I can use it because FC will have vertical component, correct, but FE and BC will not come into that equation because they are horizontal. So that's why summation of forces vertical I can use here directly, and I will get the answer in one line. Now for member force in member BC, which equation I can use? BC again horizontal, FE again unknown. See, while solving BC, I don't have any idea about FE and FC. All three are I am solving individually. Okay, then don't say sir BC are calculating because FE already we know, so I can apply summation fx. Yes, but for that I need to find out the FE value na first. So please understand the concept. I need to get the answer of FE, FC and BC individually. It is not like that if I am calculating BC, I know the value of FE or FC. I am calculating BC, it means all three are unknown, but I want to find out BC. So with what single equation I will be getting the answer? That is what my approach. For BC, summation fx not possible, summation fy not possible, summation moment is the only option. But about which point? The point where FE and FC will have a zero moment. About which point they will have zero moment? The point from which both are passing. From which point FE and FC are passing? F only. So you will write summation of moment about F point is 0. So you will take the moment about this point. Moment about this point you will take 0. You will get the answer of BC very easily. So this is the method of section. Please everyone understand, the concept is very important here. So this concept if you have understood, no matter whatever kind of question they have asked, you can easily solve it. Okay, you can easily solve all of the problems. Got it? So please make a note of all this, everyone fast. Done? Okay. Now next that we have to discuss here is friction. Okay. Now again in the friction only 2-3 things we have to discuss. Truss part, zero force member, it is clear. Method of section, it is clear. Now coming to the friction chapter. Okay, in friction the formula that we are using is mu into n, but here only maximum people will do mistake here. First of all, this friction force is the maximum value of the friction force and mu is the mus, static coefficient of friction. Whenever I am using a formula mu into n, mu is our static coefficient of friction, and when I am using static coefficient of friction, this value of friction is the maximum value. Okay, so first we have to understand whether the maximum friction force is acting or not. If it is confirmed that maximum friction force will be acting, then only I can use this particular formula. Otherwise, I can't use this formula, right? So this friction force have maximum value which is mus into n. Got it? So maximum static friction force we call it. Maximum static friction force. Now, there are 3 cases that we need to understand here. If all 3 cases you have understood, then all the friction problems you can easily solve it. Right? What are the 3 cases? Let's suppose case first. This is the force P which is applied on the block. Now, what you will do? You will draw the free body diagram. Okay, I told you the basic concept here is to draw the free body diagram. This is force P This is the normal reaction you will be having. This is the self weight, and the friction force will be acting like this. Now, I don't know whether this friction force is what maximum value or not. I don't know at this moment whether it is maximum or not. Okay. Now, one thing you should understand here. This is the free body diagram we have drawn. Now, what I need to do, first of all, calculate the maximum friction force value only. Calculate this value by using mu s into n. N value you can get very easily. How? Summation of forces in vertical direction 0. Because of this force, it cannot move in vertical direction. It will be having a tendency to move in horizontal direction. In vertical, the net force summation is always 0. So, if I apply summation of forces vertical 0, normal will be equals to W. So, that value you will be getting. If you put here, you will get some value. You have to compare the value of P with this maximum frictional force. Now, if P is less than the maximum value of friction force, what does that mean? The body will be under static equilibrium. Okay, so this is the thing that we need to check first of all. Calculate maximum friction force, compare it with the external force, and if external force is less compared to maximum value of friction force, then it is static equilibrium. Now, you will be asking, sir, in that case, what is the friction force? In that case, friction force simply you can apply, because as it is a static equilibrium, summation of forces in horizontal direction also is 0. Summation of forces in horizontal direction is also 0. Why it is 0? Vertical it is fine, we understood it is not moving in vertical direction. So 0 summation of forces. But in horizontal direction, why it is 0? Because we have confirmed this thing, body is in static equilibrium. Once we have confirmed this thing, summation of forces along horizontal direction is also 0. By applying that equation, we will be getting the answer of friction force as well. Okay. So that is the case number 1. Now, the second case. Same body we are having, and let's suppose again force P. Again, a free body diagram you have to draw. Force P we are having. This is self weight W, normal reaction, and this is what the friction force. Now here again maximum friction force value you will calculate, but in this case you have find out P is actually equals to maximum value of friction force. So what does it mean? This is also a case of static equilibrium. This is also a case of static equilibrium because the force, external force is exactly equal to your maximum frictional force value. Your P value is actually equals to maximum frictional force value, na? Right? So under this case also body is under static condition. It is not moving, but this condition has some special name. It is known as impending motion condition. Okay, so first we have confirmed it is static equilibrium, but this condition is special condition because both the values external and friction force are balanced. So this condition is having one more name which is known as impending motion condition. So this word is important. Which means about to slide, body is about to slide or on the verge of sliding. It is on the verge of sliding or about to slide, about to move. This kind of thing you can understand from here. See, body will be able to move only when it has overcome the maximum frictional force value. Once the body has overcome the maximum value of frictional force value, then only it will be under dynamic case. Body means the external force is more than friction force value, then only it will move, na? Very basic concept here. So in the third case, so again same free body diagram we will be having. If P is greater than maximum value of friction force, you will say what will happen? Body is under dynamic condition. And in this case, friction force is actually the dynamic friction force. And for dynamic friction force, we will have mu into K. Mu K basically, mu K is the kinetic coefficient of friction. We will not be using static coefficient of friction. This is kinetic coefficient of friction. Is it clear? So it is now kinetic coefficient of friction. When we have to use kinetic coefficient of friction? When we have confirmed this thing, the body is under actually motion. Once you have confirmed this thing, the body is under motion, then only we will be using mu k into n. Otherwise, mu s will be coming. Right? Very basic point I've discussed. So this is all about the friction you should know. Okay. And one more thing regarding this friction, one more concept, that is angle of friction. Sometimes instead of giving coefficient of friction, it will give you angle of friction also. So you should be aware of this angle of friction as well. Let's suppose this is the external force P is acting, and this is the normal force, and this is what friction force we are having, and this is the self weight. So directly free body diagram I have drawn here. Now let us take this is the maximum value of friction force. Obviously normal reaction and friction force are perpendicular to each other. There will be some resultant. Let's suppose resultant is R. The resultant, let's suppose resultant is making some angle phi from the normal. Okay, that phi, if I have to write as tan of phi, it will be equals to what? Perpendicular, that is maximum value of friction force divided by perpendicular upon base, that is n. Maximum value of friction force is mu s into n. Okay, n will get cancelled out. Finally, I can write tan phi value equals to mu s. So whenever angle of friction is given directly, just take the tan of that particular angle, you will get the coefficient of friction. Okay, so whenever angle of friction is given, you just need to take tan of that particular angle, you will get coefficient of friction. Okay, this is also very important thing. Okay, because sometimes they will not be giving you mu, coefficient of friction they will not give, they will give angle of friction. So use this relation to get the value of mu. Got it? Done everyone? Now just we will move on to the centroid and moment of inertia part. Directly some relations you need to know. Okay, some of the direct relations we need to remember, like, okay, so you will get all these relations in your PDF itself. Okay, so that previous one is for the centroid part, that basic centroids we at least need to know, and this is what the moment of inertia. Apart from that, okay, apart from that, what is we need to remember here is parallel axis theorem. Okay, now in parallel axis theorem what we will do, there is a body having area A, right, and let us assume this is what there is one centroidal axis of the body. This is the centroidal axis of the body, and you want to calculate the moment of inertia, area moment of inertia of this body about any other axis which is parallel to one of the centroidal axis. Okay, and the distance between your centroidal axis and this axis about which you want to calculate moment of inertia. Let's suppose axis is AB. There is some body having area A. This dotted line represents the body's centroidal axis, and you want to calculate the area moment of inertia of a body about any axis which is parallel to this axis AB, parallel to what? Your centroidal axis, right? So for that there is a direct formula from this theorem. Area moment of inertia of a body about AB will be area moment of inertia of body about its own centroidal axis plus area of a body multiplied by distance square. Which distance? Distance of centroidal axis and the axis about which I want to calculate MOI, moment of inertia. Remember how to use this equation, very important. Again I am telling you, whenever there is a given body and you have to calculate the body area moment of inertia about any axis, but condition is what? That axis should be parallel to one of the centroidal axis of body itself. that axis should be parallel to one of the centroidal axis of the body. When it is confirmed this axis is parallel to one of the centroidal axis, I can use directly this relation. Okay, so with this relation I will get the moment of inertia value about AB. A is the area of a body, D is the distance between your axis about which you want to calculate MOI, and another axis is what? Centroidal axis. The distance between the axis is D. Is that clear? Clear? So that is what parallel axis theorem. Now one more theorem is there, perpendicular axis theorem. So parallel axis theorem is clear. Now one more equation that theorem we should remember here is perpendicular axis theorem. Now in this case what happens? Let's suppose there is a body we are having. Okay. Now see everyone. This is x axis and this is y and y axis, and there is one axis parallel to perpendicular to xy plane, which is z axis. Now the axis which is perpendicular to a cross section, it is known as normal axis, but if that normal axis passing through the centroid, in that case it is known as polar axis. Okay, polar is a normal axis, fine, which is perpendicular to a given cross section. Okay, normal axis perpendicular to a given cross section, but the normal axis will be called as polar axis when that normal axis is passing through the centroid of the cross section. Now if you want to calculate the area moment of inertia of a body about this polar axis, what you need to do? Simply add the area moment of inertia of a body about x and y direction. Simply I will be using this relation to get the perpendicular. If I use this relation from this perpendicular axis theorem, I will get the moment of inertia about the polar axis. Got it? Like we have used parallel axis theorem. So where we have to use parallel axis theorem and where we have to use this perpendicular axis theorem, I hope it is clear to everyone. Right? So this much basics we have completed. Now a quick discussion about the vibration, and then we'll finally cover our dynamics part. Okay. So as vibration, a very small topic that was a few years back, recently added also in civil engineering. Only basic questions they are asking. If you see all your previous year questions from vibration, these are very straightforward numerical, direct formula based questions they have asked. So in vibration, only 2 to 3 things you should remember. Okay, for this civil engineering, for mechanical, it is all about like in a complete detail we are having. So you can't compare it, this vibration, with our mechanical theory of machine vibration. Okay, you should not compare this vibration. Okay, and one more thing, tomorrow we will be having theory of machine smart revision session tomorrow. Okay, again same timing 6 to 7, theory of machine sessions we are having for mechanical tomorrow. Okay, in that you will see what is the vibration and what kind of depth we are having in mechanical. Okay, vibration. So first basic thing that you should understand, for a spring mass system, what is the natural frequency we are having? Okay, so the natural frequency that omega n we are having is under root k by m, unit radian per second. Now first of all, k has a unit in Newton per meter. Remember this thing, k should be in Newton per meter. Most of the time it will give you, they will give you like Newton per mm, Newton per centimeter. Convert back into SI unit. This should be the unit which is used in this formula. Many times formula is correct, you will do the unit mistake. That should not happen. Kilonewton per meter they will give, again convert back into Newton per meter. Then you have to use in the formula. So that is omega n. Time period of oscillation is 2 pi by omega n, unit second. Frequency, natural frequency in terms of hertz will be 1 by t, which is omega n by 2 pi, and it is expressed in hertz. Okay, and what is hertz actually represents? Number of cycles per unit time. Hertz basically give you the number of cycles per unit time. Okay, so omega n they are asking, natural frequency they have written, either it can be in radian per second or it can be in hertz. So please understand in which unit they are asking. They will simply mention find out the natural frequency, in bracket small they will write radian per second, or they can write in brackets hertz. So you have to know about like which unit they have asked. The idea of a unit should be clear, otherwise just you will see natural frequency, you will apply this formula and you will get wrong answer. Why? Because in the brackets they have mentioned hertz. You have used this formula. Okay, now this is simple spring mass case. Now another modification that we can have is, in this case also you will have same answer. Or let's suppose if I use inclined plane. If I use inclined plane M, like this. So in this case also the same formulas will be valid. Now next thing, if the springs are in series or parallel, that basic thing you should understand. Combination of springs. Okay, so for first of all series case. Okay, how to identify series case? End-to-end connection will be there. Okay. This is what known as end-to-end connection. Okay, and if I talk about parallel case, okay, you will have parallel case like this. Like this. So let's suppose stiffness K1, stiffness K2, stiffness K1, K2, right? Now how we will write the formula here? See, in the case of series, the formula will be 1 by K equivalent by K1, 1 by K2. And here the stiffness, equivalent stiffness will be just we need to add K1 plus K2. Okay. Now what is the differentiating thing that between series and parallel? How you will identify? In series case you will be having same load, but in parallel case you will be having same deformation. Both the springs will have same amount of displacement. Both the springs will have same amount of displacement. In this case both the springs will have same amount of load. Okay, understand the basic difference. Diagram everyone understands, but actually if I ask some basic details like what is the main difference? In series the force, the load on the springs is same, and in this case displacement of both the spring is same. So that basic understanding you should have about the springs. Clear? Now one more small things we have to discuss regarding this vibration. Let's suppose they have given some beam and they have asked, okay, some mass, point mass they have mentioned in this cantilever beam. What will be the vibration, natural frequency of vibration? We'll be using the formula G by delta, again unit radian per second. Delta is the deflection of cantilever beam. Okay, when point load is acting at free end. So obviously this thing you will be getting from strength of material, right? All the formulas, maybe you have written the formula sheets, na? So from the formula sheets you know at free end if load is there, point load, what kind of deflection you will be having, like WL cube by 3EI. So that basic formulas everyone should remember. Okay, so that is what the last thing that you should understand in your vibration part. Now we will move on to the dynamics part. Okay, in dynamics many people are having confusion. I will write all the formulas in such a way that you can remember all the formulas and all the concepts you will be getting within 1 or 2 pages itself. Engineering mechanics is the only subject in which you will find very less number of formulas but huge number of problems you will get, huge different variety of problems. Okay, different variety of problems you will be getting. Formulas are what less, in fluid mechanics, in strength of material, in different subjects you will have a more number of formulas. But in engineering mechanics, less formulas, more variety of problems are there. Less formulas and more variety of problems. Now, coming to the dynamics part, see. So, in dynamics, we have two parts. Kinematics and kinetics. Okay. So, dynamics have two parts, kinematics and kinetics. Okay. Now, in kinematics, first of all, I will be discussing kinematics. All the formulas in kinematics I will write first, then I will write for kinetics, right? Okay. See. So, as I told you regarding kinematics, we will be writing. So, okay, in the next page I will write. Now, either the body can have a translation motion or rotation, both kind of motions are possible, right? First I will write for translation, and if you know the translation, immediately you can write for rotation as well, very easily. So, in translation, the formula first of all is velocity, ds by dt, unit meter per second. Acceleration, dv by dt, meter per second square. Now, the third equation that we have is ads equals to vdv. These are the three fundamental equations for translation motion. Now, similar fundamental equation for rotation we are having, omega equals to d theta by dt, rate of change of angular displacement, unit radian per second. Acceleration, angular acceleration, d omega by dt, unit radian per second square. Then we have alpha d theta equals to omega d omega. These are the fundamental equation. These are the fundamental equation of motion for translation, and this is for rotation. And this is for rotation. Now, this is clear. Now, next, again, first translation we will be writing. First translation, and then parallelly we will be writing for rotation as well. Okay. Now, let's suppose acceleration is constant here. Okay, linear acceleration, and this angular acceleration is constant here. So, how we will write the equation of motion? How we will write equation of motion? See, first we are having v equals to u plus at. You have already learned this topic in your school level also. We will have s equals to ut plus half at square. Then third we are having v square is equals to u square plus 2as. Okay. Now, parallelly we will write for rotation as well. See, omega equals to omega naught initial angular velocity into alpha into t. Here, let's suppose angular displacement theta, omega naught into t plus half alpha t square. Then we have finally omega square equals to omega naught initial angular velocity plus 2 alpha into theta. This is what the basic equations of motion, if acceleration a constant and alpha constant. This we will be writing. And these are what known as fundamental equation of motion. These are valid for all type of cases. Fundamental equation of motion. Clear? Yes or no, everyone? Tell me fast. Great. Now, moving ahead here, some of the things like regarding accelerations we should know. Okay. See, whenever something is under rotation, let's suppose this is point A and it is having a rotation omega. This is point O. So, two types of accelerations will be involved. There is tangential acceleration and there is what? Normal acceleration. It is equals to r omega square and it is equals to v square by r. Okay, let me write it here. V square by R. Okay. Let me just correct here. It is R alpha. It is R alpha, right? So this is the tangential acceleration R alpha, and this is V square by R, or we can write as R omega square, because V equals to R omega, right? So let's suppose V square is there, so it will be R square into omega square. So if you write it is V square by R, V square value R square into omega square, if you put, so this R is there, so it will get cancelled out, right? So you will be having finally R into omega square. So both R omega square is also there, V square by R is there. So both the formulas you will write based on the value given, like omega is given or V is given. Okay, understand? So normal acceleration V square by R or R omega square, because we have a relation V equals to R omega. So V square will be R square into omega square. That value you have substituted R square into omega square. This R square get cancelled out, so only R is left. Now one more thing. What actually it represents? Tangential component of acceleration is telling us the rate of change of magnitude of velocity. Normal acceleration represent rate of change of direction of velocity. Velocity is a vector. It has magnitude as well as direction. If magnitude is changing, tangential acceleration will come. If direction is changing, normal acceleration will come. Now, very basic fundamental thing, if something is rotating, direction is always changing. So it will be there always. Normal acceleration is always present and direction is towards the point of rotation. Towards the point of rotation it is there. And for tangential component of acceleration, it is along the velocity vector if velocity is increasing. And if velocity is decreasing, just opposite to the velocity vector it will be there. Formula R alpha. Alpha is angular acceleration. It is equals to d omega by dt. Omega constant. Angular velocity constant, alpha 0, tangential acceleration 0. Are you getting the things? Yes or no? So this basic things at least you should remember. Okay, so I will just write it here itself. The basic meaning here. Represents rate of change of represents rate of change of magnitude of velocity, and it will represents rate of change of direction of velocity. Got it? So direction changing, then normal acceleration will be there. Now if any body which is having a constant direction, it is moving, let's suppose pure translation it is having. So what about this normal component of acceleration? 0. Normal component of acceleration will be 0, na? Very basic point. Again, another logic I can give you. Let's suppose if the body is sliding. So for sliding body, we will say the point of rotation is at infinity. So it means radius will be infinity. So if you write normal acceleration component V square by R, 1 by infinity is what? 0. So this much I think basics you should know. What tangential acceleration is representing, what normal acceleration is representing. Normal is always towards the point of rotation, and tangential is along velocity vector if the velocity magnitude is increasing. If it is decreasing, it will be just opposite to the velocity vector. Got it? Now some formulas regarding, so this we have discussed in the kinematics part. Now one last thing regarding rolling, we should note it down. Now in rolling what happens? Body is under rotation as well as translation. For pure rolling case, velocity equals to R omega and acceleration, linear acceleration is R alpha. Now this linear velocity and this linear acceleration is valid for all the points. Remember this point. Okay. So when the body is under pure rolling motion, how we usually understand this kind of motion? We will take, okay, first pure translation, then we will take pure rotation. So if translation is there, it means every point is translating with same velocity and same acceleration. But if it is under pure rotation, this will be moving, this will have a velocity vector like this one will have like this one will have like this, and this one will have like this, because it is rotating like clockwise. So this is, we have translation. And this is what? Rotation. Translation and rotation. Clear? So it is a combination of translation and rotation. Right. Now next, quickly we'll write down some formulas of the kinetics as well. Right. Okay. In kinetics, the first formula that we are having here is, please try to understand the kinetics formulas. First of all, Newton's second law, mass into acceleration, but acceleration belongs to center of mass, and force direction, the net force direction is along the acceleration only. In terms of rotation, how you will write? Torque equals to I alpha. I is the mass moment of inertia into alpha. Second formula, the work done, which is actually F dot ds. Okay, it will be equals to change in kinetic energy. Okay, and kinetic energy for translation is half mv square. Half mv square, final kinetic energy minus initial kinetic energy, half mv square, but for initial. Right. In terms of rotation, it will be written as work done as m d theta. Again change in kinetic energy, but rotational kinetic energy, that is half I omega square. Okay, final minus half I omega square initial. Right, like this. Now third formula that we need to remember here is impulse momentum equation, linear impulse. So F dt, okay, 0 to time t equals to final momentum minus initial momentum. Now in case of rotation, we have what? Angular impulse. Here we are having linear impulse. F dt is linear impulse. Here we will be having angular impulse, which is m dt. Again 0 to time t. Okay, and it will be angular momentum change. Angular momentum is I omega final minus I omega initial. So Newton's second law, work energy principle, and momentum equation. Angular momentum equation, linear momentum equation. Right. So linear impulse equals to change in linear momentum. Angular momentum, angular impulse equals to change in angular momentum. So these is all about the kinetics part. Okay, all these three formulas we should remember. This is valid for translation, this is valid for rotation. Clear? So the formulas you should know. Translation case and this rotation case we are having. Is it clear, everyone? Yes or no? Now in the last we will be having, the only last thing is Lagrange equation. Okay. In Lagrange equation, what we have? Okay, first of all you need to know about the Lagrange function, difference of kinetic energy minus potential energy. This is the first thing. Now the equation, the main equation, how we will write? D by dt of dou L by dou x dot minus dou L by dou x equals to 0. L is the Lagrange function. L is the Lagrange function, right? And one more thing, x is what? The independent parameter which will actually define your system. Okay, so this is all about the dynamics part and the Lagrange equation. And one more small things regarding the collision of elastic bodies that we should know. Okay, let me just add one more page here. So this is the last thing that we are going to discuss. So what happens, like this is the velocity u1, this is another body having velocity u2. So this is before impact. Okay, before the impact or before the collision we are having, and after the collision we have, let's suppose v1 velocity, and for another body we have velocity v2. So before and this is after case, before impact and after impact. So we will be having like the momentum value m1 u1 plus m2 u2, as there is no external force involved here, and here it will be m1 v1 plus m2 v2. So according to the conservation of linear momentum, we will be just equating initial momentum and the final momentum. Okay, so as per the conservation of linear momentum, m1 u1 m2 u2 equals to m1 v1 m2 v2. This is the first relation. Another, coefficient of restitution, which is the ratio of relative velocity of approach. Relative velocity of approach. Relative velocity of first we will have separation, then in the denominator we will be having relative velocity of approach. Relative velocity of approach. So here in this case we will be writing v2 minus v1 divided by u1 minus u2. And very important point you should understand here, all the velocities we have to take about the common normal, okay, or the basically the line of impact, we can say line of impact. All the relative velocities we have to write about the line of impact. Line of impact is the common normal. Whenever the bodies are having contact, the common normal we are having, that common normal is our line of impact. So the velocity we should be writing about the line of impact. Okay, if there is some angle, so we will write the component of velocity along line of impact, and that velocity we are going to consider here, right? So please understand everyone, these are the quick formulas that we have written here. Okay, this is all about the kinetics part. This is about our kinematics. Okay, this is about kinematics part. So fundamental equation of motion, when acceleration is constant, this equation will use. This acceleration tangential normal we should know. This is about pure rolling, and this is all about the kinetics part, where the force is actually included in the analysis, right? So all of the important formulas and the relations in entire engineering mechanics we have discussed in this particular session. So you can make a note of all these formulas here, and I will wish you a best of luck for your GATE examination. Please try to revise as maximum as possible. And in this last, if you have some mock tests available in the IMS GATE Academy, you can opt for those mock tests, so that at least you will be having some idea, okay, how the actual paper will be coming. Okay, so please try to give the mock test as well. And whatever the formula sheets you are prepared, daily do revisions for all the subjects, right? And in the last, again, I want to just inform you students regarding the Telegram group. Please understand, this is the Telegram group in which you will be getting everything regarding job notifications, detail you will be getting, apart from daily quiz, which will help you for all technical subject preparations. And apart from that, lecture PDFs that we are conducting in YouTube, all the lecture PDFs you will be getting there, and all the latest update about the YouTube lectures. And last thing about our IMS GATE Academy online live program, which is having more than 800 hours of sessions, right? Apart from that, you will be getting 12 mentorship sessions and theory book, exercise book for the practice you will be getting. You don't need to depend on any other source of reference. With this single theory and exercise book, your entire preparation of the GATE will be done. And if you want to have a free counseling session about how this program is all about, and if you want to just have a quick understanding of the sessions, like what kind of program features we are having, and you want to have the counseling sessions, you can just call on these numbers. These are the numbers, okay? It is also mentioned in the description box. So you can call on this number to book your free counseling sessions as well. Okay. Thank you so much, guys, and all the best for your GATE 24 examination. Thank you.